Welcome to another edition of Math Teacher to Go. And today we are going to look at some more interesting concepts about functions. This is the second of 3 videos dealing with functions and function notation and how we deal with them, how we graph them. So today we're going to look at something called function notation. In the first video we looked at how to tell if a relation is a function from a set of points, a graph, or an equation. So we're going to work with equations and graphs mostly today, but the first objective we have is to look at using function notation. We have all seen equations like that, and this says if you want to know the y coordinate that goes with some x coordinate, here is how you find it. You plug in the value of x, multiply it by 3, add 2, and that number tells you that the x you chose with the answer you got is a point on your graph. You've done this with lines, hopefully you've done it with other types of equations too. But it's instructions, and the output of the instructions, after you put a number for x there and follow the instructions, is a y coordinate. Function notation is exactly the same thing. We're just going to replace the y with something. So it's just another way to write that. It's a set of instructions. So if we look at y equals 3x plus 2 and we write it in function notation, and I'll name my function f. That's typically what we start with, but you can name it anything. I get f of x, that's an x, equals 3x plus 2. Look, it's exactly the same. I want to fix this x here. F of x equals 3x plus 2. This is y. Once you calculate f of x, you found the y coordinate that goes with some x. So the instructions here, this x means that's your variable. It says that's the letter you're going to replace with numbers to calculate y's. Here is your x, and when we use function notation, I tell students you should put parentheses around your variables, and you'll see why in a moment. So this says f of x is some equation, what we call in terms of x. When you hear this phrase in terms of, and there's a variable after it, means there's a letter after it, that's the variable. So that means the x here is a placeholder. It says when I replace this x, I replace every x on this side. The other thing we see is f is the function name, function f. F of x can be thought of as y. This is how I find y. Here is f of x. In other words, here is how I find y. And x is the variable. And then the x here says when you look at the equation on the other side, x is your variable, it's in terms of x. So you don't have to have your function name f, and your variable doesn't have to be x. I could have some g of a equals 3a plus 2. Turns out if I graph this on an axis where g of a is on the vertical axis and a is on the horizontal, I get the same graph as I would for f of x equals 3x plus 2. But here the a is the variable, and that's what this tells me. We oftentimes see other letters used. H of t is popular in physics class. Negative 4.9 t squared. That's a common thing. Now in this one, when you put parentheses around the variable, you don't include the squared because you can replace the t with a number and then you're going to square it. So if the function name is f and the variable is x, then x is the placeholder. When the function name is h and the variable is t, then t is the placeholder. If I want to know the height at some time, typically in physics this is what you're doing. You drop the ball from a building or something. If you want to know the height of the ball at that time, then it will have dropped this much, negative 4.9 t squared. It is helpful when you're evaluating functions, like if you had a particular time, to first look at what do I have to replace? This f of 2, you see this f of 2? I have a 2 there, but I have an x here. What this tells me is everywhere I have an x, I'm going to replace it with a 2. So I would rewrite my equation like this, my function like this. I would put parentheses around each x. So now when I want f of 2, I have 3 parentheses 2 squared. And by the way, this becomes really important, these parentheses, when you have negative numbers and you're squaring them, plus 2 parentheses 2. Notice I'm keeping the coefficients, the 3, the 2, x was squared after the 3, x is just by itself after 2, and there's still the minus 8. The reason I suggest the parentheses is students often forget to make the substitution in all the places. There's 2 x's here, you'd have to replace both of them with 2's, and they forget to square numbers or square negative numbers properly. So once I do that, I can now find what y is when x is 2 by calculating this using proper order of operations. That would be 3 times 4, 2 squared is 4, plus 2 times 2 is 4, minus 8. So I did the exponents first, and then I saw there were no more exponents, so then I did this multiplication. And now I have to do 12 plus 4 minus 8. I move left to right doing addition and subtraction in the order they appear. So I get 16 minus 8, or I get 8. So that tells me the point 2, because that's the number I used for x. 8, that's my y, is on the graph of this function. So I'd like you to pause the video and try, I think I have 2 problems, I have 3 problems here. Problem 3 might stump you a little, but follow the process. Try these 3 problems and come back and we'll go through the solutions together. But make sure you try them before you come back. Okay, you've tried the 3 problems, or maybe you've tried one and just want to check that one first. That's okay, I'll pause before I do the second one. So I have f of x equals 3x plus 2, and I'm asked to find f of negative 7. So I have f of x equals, and notice I'm going to write the function again. And it's not that easy to write with the tools I'm using to make this video. So if I'm willing to do it, you should be. Then I have f of negative 7 equals 3 times negative 7 plus 2. There's no exponents, so I look at multiplication. There's no things in parentheses need to be simplified either. So I get negative 21 plus 2, which is negative 19. When I add signed numbers and the signs are different, I subtract. 21 minus 2 is 19, but then I keep the sign of the larger value, which was the 21. So I get f of negative 7 equals negative 19. The point negative 7, negative 19 would be a point on the graph of this function. All right, if you didn't try problem 2 yet, go back and try it, and I'll do that next. Okay, problem 2, our function is no longer f of x. Our function name is g. Our variable is a. The process is exactly the same. So I have 2 parentheses around the a cubed minus 4 parentheses around the a squared plus 7 parentheses around the a minus 15. I write out the whole function but put parentheses around the variable. So everywhere I see an a, I'm going to replace it with a negative 2. So I get 2 times negative 2 cubed minus 4 times negative 2 squared plus 7 times negative 2 minus 15. So I do exponents first. So I'm going to have 2 times. Now when I cube negative 2, it's negative 2 times negative 2, which will be positive 4. When you multiply sign numbers, if the signs match, you get a positive number. So then I have a positive 4 times a negative 2. The signs don't match, so I get negative 8. I'm just going to put that in parentheses to make it clear I'm not subtracting. Minus 4 times negative 2 squared is positive 4. If you do that in your calculator and it tells you negative 4, it's because you didn't put the negative number in parentheses. It would do the exponent first, then the negative. You want negative 2 times negative 2, which is positive 4. And I don't have any more exponents to work with. I will just make the order of operations clear here by writing that out. Now, I multiply left to right as multiply or divide. There's no division here, but if this was division, I would do that first. You don't just do the multiplication first. I get 2 times negative 8 is negative 16 minus, now a lot of students do negative 16 minus 4 and then multiply by 4. Don't. You have to do this piece here. That's the multiplication. So I get minus a 4 times a 4 is a positive 16, plus a 7 times a negative 2 will be a negative 14 minus 15. Now I have all these sign numbers to add. I move left to right doing addition or subtraction in the order they appear. I do not do this addition first. I have a negative 16 minus another 16, that's minus 32, plus a negative 14 minus 15. And that's going to be, now I do the negative 32 plus the negative 14. That's a negative 46 minus 15. A negative 46 plus a negative 15. That's what you're doing when you're subtracting. The signs are the same, so I add them. I get 61, and I keep the sign I had. Since the signs are the same, I get negative 61. So this tells me that if I were graphing function g, negative 2, negative 61 would be one of my points. Hopefully my arithmetic was correct there. If you have any questions, you can email me. Now, for the third one. If you haven't tried the third one yet, stop the video, go back and at least look at it, and do the first step, which is putting parentheses around your variable. Okay, so if you're back, we're about to go through this process. The process is very much the same. I'm going to do negative 16. T was my variable, so I'm going to put parentheses, plus 20, I get a t there, plus 10. So everywhere I had a t, I'm going to replace it with a t plus 1 to get h of t plus 1. So h of t plus 1 equals, let me erase this here. We'll start that again. I don't know why it won't get, there's my pen. All right, negative 16 t plus 1 squared. See where I have a t? I now have a t plus 1. Plus 20 t plus 1 plus 10. So when I'm finished, I'm not going to have a number for my answer. If there's t's or x's or a's in what I'm replacing my variable with, there will be in my answer. Now the other thing is this t plus 1 squared. That's not t squared plus 1. You have to FOIL that. You do t plus 1 times t plus 1 to get that. And I'm just going to do that off to the side here. I get t squared from the firsts. The outers are 1t, the inners are 1t, so I get plus 2t plus 1. So I get negative 16 t squared plus 2t plus 1 plus 20 t plus 1 plus 10. So I took care of the exponents. Now I'm going to distribute where I need to distribute in group like terms. So I get negative 16t squared minus 32t, because negative 16 times 2 is negative 32, minus 16 plus 20t plus 20 plus, that's a 20, plus 10. Negative 16t squared is the only t squared, so I can't combine it with anything else. But I see I have a negative 32t and a positive 20t. When I do negative 30 plus 20, the signs are different, so I subtract and I get 12. But the 32 is the bigger number, and it was negative, so I get a negative 12t. And I have a negative 16, a positive 20, and a positive 10. Negative 16 plus 20 is 4. 4 plus 10 is positive 14. So this is actually my answer. And some of you are having trouble because it's not a number, but what we're going to see in future lessons is that basically this is just the equation I would get if I shifted function h 1 to the left, and if t were seconds, it would be 1 second to the left. If I increased every time by 1, the function would actually move 1 to the left. And we'll see that in coming lessons. So if you could do that one, if you could follow it, you're understanding function notation. Now, function notation is a way to express an equation of a function, a relation that's a function, that could be seen as a graph rather than just an equation. So the way we get from the function equation, like here, h of x equals x squared minus 4, is by plotting some points, at least for now. We're going to learn some other more general techniques. You're going to recognize the shape of x squared and realize the minus 4 just moves the whole graph down 4. But for now, and any time you're stuck, plotting points is a way you can graph a function. So the way we often do this is we want a bunch of points. Rather than just get a bunch of points and randomly write them on the page, we tend to make a table. We have x, and we have h of x. So for each value of x, and I'm going to pick some negatives and some positives. I'll do -2, -1, 0, 1, 2, 3. And this is the part sometimes students have trouble with this because they want to know, how did I know to pick those numbers? Well, there is a little, I knew to pick negatives and positives, and you should pick negatives and positives. But honestly, you could have picked -4, -2, 0, 2, 4, 6. Doesn't matter. Now I'm going to calculate h of x, and h of x was x squared minus 4. So I'm going to have -2 squared minus 4, which is 4 minus 4, which is 0. So one of my points is -2, 0. The x I put in gives me the x coordinate. What I calculated is the 0. So I do the same thing with -1. The rule was you square the number and then subtract 4 from it. That's what this is telling us. So I get 1 minus 4, which is -3. So the point -1, -3 is on the graph. If I put in 0, I square 0 and I subtract 4, I get -4. So the point 0, -4 is on the graph. If I put in 1, I get 1 squared, and I'll put the parentheses just to be consistent. I also get -3. That's interesting. I get a 1 and I get a -3. And then if I put in a 2, I get 2 squared minus 4, and I get 0, because 4 minus 4 is 0, so 2, 0. It's on the graph. And if I put in a 3, 3 squared minus 4 is 9, minus 4 is 5. So I get 3, 5. So I've got all kinds of more grid space than I need here, but that's fine. I'm going to start plotting my points. -2, 0, right there. -1, -3 would be right in between -2 and -4, so it'd be right about there. 0, -4 would be right there, and we call that the y-intercept because that's where the graph will cross the y-axis. 1, -3 will be right there. 2, 0. X is 2, y is 0. Remember, you go left or right first, so I go 2 to the right. I start at the origin, go 2 to the right, don't go up or down at all. And that's called an x-intercept. Sorry about that. Let me close that. And then I have the point 3, 5. So I didn't do -3, but I would have gotten -3, 5 also. So if you're supposed to sketch a rough sketch of this graph, you might go like this and say, oh, that's a general shape that I'm familiar with. Whoops, I didn't do that very well. Try that again. And since you weren't told to end at these particular x values, you would put arrows That's not as important as just understanding the plotting of the points now. Now, obviously, I didn't do this perfectly right in here, but you get the idea. You use the function as instructions to take, and you choose these x values. Choose some negatives and positives. So next we have some practice for you, and you're going to choose negatives and positives. The numbers I did in this example would work fine, but you can choose other numbers. And I want you to pause the video and complete, I guess I only have one problem there, complete this problem. Graph f of x equals x cubed by plotting points. Alright, you're back. So hopefully you made some sort of a table of values in x and f of x. Now you're just cubing. Sometimes it's handy to write that up there. So I'm going to do -2, -1, 0, and of course I didn't make this long enough again. 1, 2. I get -8 when I cube -2. I get -1 when I cube -1. I get 0 when I cube 0. I get 1, and I get 8. I'm going to plot those points on this. So at -2, I'm at -8. Now this goes all the way to -20. 5, 10, 15, 20. So that's by fives. So I can estimate. Some students really, if there's not, you just, okay, that's about -8. -1 was -1. That's -5 right there, because this goes 5, 10, 15 in order to get down to 20. So -1, -1 would be right about there. 0, 0, 1, 1, 2, 8. And the graph of x cubed looks about like this. It should have gone through 0, 0. I'm having a hard time drawing here. Let me see if I can. And I know at 3 it would be way up there somewhere. And since I'm not told those are the only x values I can use, just do that. Now that's a real squiggly, ugly curve, but it gives you some vague idea of the shape of that function. And you'll learn x cubed is one of the functions you're going to need to know shortly. So when you memorize the shape of that, and the shape would look more like this. That's a better picture of the shape. But you would be able to plot that right away by just picking a couple points and knowing where the rest of them go. So that's all I have for this edition of Math Teacher to Go. This was Function Notation and Basic Concepts Part 2 of 3. Hope to see you in the next video.